sugar is something that people say, well, is it good or bad? And I know it depends, and we're going to hear that a lot today. But why don't you tackle sugar? Where do we go wrong with sugar? You know, is sugar intrinsically problematic for us, or is it more the volumes that we're consuming?
Of course, I think it's the latter. It's both the quantity and the context of it. And there's been a lot of interest in terms of so basic sugar, sucrose, which is 50-50 glucose, and fructose is a disaccharide. It just means two sugars bound together. And fructose has really come under the microscope recently because it can affect our uric acid levels, which is often used, so it's a risk factor for gout, but it's often used as like a sort of marker of our metabolic health. And fructose can affect cellular energy levels if it's, in the way that it's metabolized, and it can be quite intensive on the cell, particularly in the liver.
What does that mean, cellular energy levels?
Yeah, so inside the cell, we have this energy currency called ATP. And in order to metabolize fructose, we end up using all of that within the cell. And you can get to this point where it's almost a stressor on the cell in order to metabolize it. And that's maybe one of the reasons why fructose is an issue for some people. And it's certainly, high amounts of fructose consumption and or sugar, which is 50% fructose, can increase the risk of things like fatty liver disease, which is increasingly common. Although the other side of that is that there are potentially other nutritional deficiencies that are affecting your risk of that as well, particularly choline, which is important for packaging fat out of the liver. And if you don't have enough of that, then the liver can accumulate fat with high amounts of sugar. But in reality, when I think about individual food components, and there are several other things that we could talk about that are controversial in addition to sugar, but it's really the context of the sugar that we're currently consuming. And like you said, the quantities of it. I like to think that the majority of our diet should be minimally processed and nutrient-dense foods. So they, support the function of our bodies. And other than just being a source of energy, there's nothing else in sugar that's really beneficial. So if you're consuming a large proportion of your calories from sugar, you're not consuming foods that have nutrients in that are then important for doing everything else. And that's really the same with all ultra-processed foods or highly processed packaged foods. They're generally nutrient poor, calorie dense. They negatively affect our ability to understand our hunger and satiety signals. And we know that we overconsume them because they're hyper palatable. We eat much more of them than we would of something else that's less processed. And people get into the issue of what processing actually is or what processing means. And so like the definition of ultra processed foods basically means that it's highly refined and they've usually added additives, fillers, and things like that in order to keep it shelf stable. So you can just like stick it in a packet and it can stay there for months or years on end.
Years on end.
Yeah. And so I don't particularly ever focus on sugar individually because it would be very easy to remove sugar, but you just replace it with some other highly processed food that is going to have the same effects because it's outcompeting more nutritious foods. So in general, I would think about the entire dietary pattern because there's no evidence that some sugar is detrimental to our health, really.
But what do you mean by that? Because some people are going to go, what do you mean? Wait a minute, I thought sugar was bad for me. Yeah. So when you say there's no evidence that some sugar is detrimental, just expand on that a little bit, Tommy?
Yeah, so in general, if you are eating within your caloric requirements and you're otherwise healthy, then consuming some sugar doesn't really seem to have a negative effect, right? It's a source of energy. There's no real reason to assume that, a large part of our metabolism runs on glucose. When we metabolize fructose, which is the other half of sugar, it gets turned into glucose. It gets used as an energy source. So if you're in otherwise good health and you're eating, consuming enough of the nutrients in general from your diet, there's no reason why sugar should be detrimental. It's when it then becomes the major source of energy and you're not getting all these other things that we might need from our diets. So usually when people cut out sugar, what they've done is they've dramatically improved the quality of their diet because they're eating other things now. So I'm not exonerating sugar in itself, but I think that focusing purely on that doesn't really tell us the greater story of what's the overall quality of your diet and what's the overall sort of balance of nutrients that you're taking in, and fiber and other things.
And I think, again, it's that point of context and what else is going on in your life kind of influences whether sugar's a problem for you or not. And it's interesting, Mark Sisson, would you call him a paleo guy, or, primal, yes. And Mark, for people who don't know Mark, I think he's just gone 70 years old.
Yeah. He's in fantastic shape. Eats a very primal, ancestral way of eating for a number of years. He's been talking about it, promoting it. But if he ever tweets about the fact that I think he enjoys sugar in his coffee each morning, like 1 spoon of sugar. Oh my God, people go nuts on it. And I would imagine that really speaks to exactly what you're saying, that 90% of his diet is really good. Yeah.
Whole foods, nutrient dense. He's fit and active. He moves his body every day. He looks after himself. In that context, 1 small spoon of sugar in a coffee each day is probably not a issue, right?
Yeah.
In that context.
Yeah, absolutely.
Someone else who, let's say, has a highly processed food diet, eating to excess, not because they're lazy or gluttonous, because they struggle. We all struggle, right? In that context, they may find that sugar or the amount of sugar in their diet is problematic. Is that another way we can look at this?
Yeah, I think so. And some of it can also be, there's a big debate in the scientific world as to whether sugar is addictive or not. And you'll have people who have some evidence on both sides. And
sounds like most things these days.
Like most things. And I would say that I'm not really sure. Like in some people who consistently overeat, they do get a large activation of reward centers in the brain when they eat sweet things. Whether that's the same as addiction is very difficult to really parse out, although some people certainly have very problematic eating behaviors, and that's its own psychological disorder that requires specialist intervention. But you're right that when we think about how we respond to certain foods, part of the problem and with the processing is that, and so when you're taking refined sugar, you've extracted it from sugar cane or sugar beets. You've taken it, or we're as a species, we very regularly have consumed sugar either from honey or from fruit, right? And nobody would tell you that eating an apple is going to be bad for you, even though there's a few grams of sugar in there.
Well, some people would these days, actually, but generally,
that I think we can say is, I'm confident saying that's not correct. But when you process foods with industrial modern methods, you divest the calories from their context. And so
divest is a big word, Tommy.
Sorry,
what's another word for that?
You separate them out, right? So say we're historically, evolutionarily, if you did eat some fruit, you eat some sugar, and it comes in this context of water and fiber and all these other things. And the body expects some context for that sugar, in terms of, and then how it affects your physiology and your hunger signals and stuff like that afterwards. When we process those foods and strip them out, the response that you get physiologically is no longer the same from the same amount of that food. So they've done this with various grains, right? If you take a whole grain, you could cook and eat a handful of pearl barley, say. It's minimally processed. That's how it looked on the stem. It's still got all the fiber, all the context. And then you look at how that affects your blood sugar. It probably has quite a small effect on your blood sugar. If you then take that same thing and you cook it and you grind it, or you grind it and you cook it and you turn it into a paste, or you turn it into bread, it has a much bigger effect on your blood sugar. It's exactly the same thing. But what you've done is you've changed the context of the food, and then that affects how your body responds to it. So you're no longer getting macronutrients, like things like carbs and fats or protein, in the context that our bodies are used to getting them. And so that's where it starts to become problematic. So when you create processed foods, you might add sugar to something that doesn't normally have sugar in it. And then that makes you want to eat more of it because you've started to create, and that's the idea of creating hyper-palatable foods. So even savory foods have some sugar in because you start to activate different receptors. You start to then drive a greater likelihood of overeating them. So that's where it starts to become problematic.
So let's say the population we were looking at was all healthy. Everyone was of a healthy weight, in inverted commas. They were metabolically healthy. Then in that context, of course, which isn't the context we're living in today, certainly not in most countries around the world these days. If that was the situation, then sugar here or there in our tea or coffee or whatever, a sweet treat if you want. And I'm not convinced I love the word treat, but I think people know what we mean when we say that. Maybe once a week or once a fortnight or whatever, or whatever you choose to do may be okay.
Yeah.
How does that, though, sit in the context of what we have today? So we know in the US, for example, what is it now? Is it 90% of US adults may have some degree of metabolic dysfunction?
And actually the UK and Europe and most of the world are catching up. So we can't even single out the US anymore.
So if we're saying the bulk of the adult population, and it's not just adults, I know, but the bulk of the population, unfortunately these days have a degree of metabolic dysfunction. So the way they're processing energy in the body is not as efficient as it could be. And that's leading to an increased risk of all kinds of diseases. In that context, is sugar now becoming even more problematic?
It's absolutely contributing due to the way that we're using it. But again, I think it comes down to the entire context of the diet, because you could certainly get to a point where, say we dramatically reduce sugar in foods, if that then comes with like a parallel decrease in overall caloric intake, say, there will absolutely be benefit. But when other people are in charge of creating these foods, these ultra-processed foods, those sugar calories are just going to be replaced by something else, and you're going to overeat it just as much, and it's not really going to change anything. So I think that if by reducing your sugar intake, you decrease your overall caloric intake and you improve your the overall quality of your diet, that's absolutely going to be beneficial. But if that doesn't happen, and this often happens with the way that we engineer foods nowadays, is just it'll be replaced by something else, and it may not make the same difference. So I think it really depends on how that gets enacted. If you say that I want to reduce I'm going to focus on sugar, and you focus on reducing sugar intake, and then with that comes, you're not eating cakes or biscuits, and with that you've dramatically both decreased your overall energy intake and improved your diet quality. That's going to come with health benefits. But it's if you then say, well, I'm not going to have cake, but I'm going to have an extra serving of fries instead, right? There's no sugar in that, but I'm not convinced you're not going to get any healthier. So it really depends on how those changes, then what the knock-on effect is.
When we think about sugar, do we need to think beyond just actual table sugar that we might put in stuff or might be added to biscuits and cakes and pastries? Do we also need to be thinking, in your view, about blood sugar spikes? So, for example, 1 teaspoon of sugar in, let's say, a hot drink, that probably is not going to have as detrimental an impact, or as significant an impact, I should say, on our blood sugar than, let's say, a modern healthy cereal, or a cereal that's marketed as healthy. When we know that you have a bowl of those, you can have the equivalent of far more than just 1 spoon of sugar in. Yeah. So I think sometimes when we think of sugar, we're not really... And maybe it's the way we communicate as healthcare professionals. Sometimes it's not just sugar, is it? It's also foods that are turned to sugar in your blood.
So the vast majority of carbohydrates will get converted to either or get converted into glucose, which then will at least temporarily increase your blood sugar in response. And I think in general, that can be normal, right? We don't want to pathologize. That's another fancy word. We don't want to create a disease out of spikes in blood sugar necessarily. Of course, there's lots of evidence that suggests that having better control of your blood sugar is associated with better health outcomes, particularly as if people go into, say, pre-diabetes or type 2 diabetes, that's associated with a whole host of long-term chronic health conditions and earlier mortality. So if you can have better blood sugar control, that's in general is associated with better health, and it particularly in those populations. If you're somebody who's otherwise very healthy and very active, and you once in a while eat something that causes a big spike in your blood sugar, I'm not convinced that's going to have a big impact, right? It's all about the context, like you talked about earlier. But you're right that anything that we eat that has carbohydrates in will increase your blood sugar to some degree. And there's some evidence to suggest that if you can make that spike lower, and you can do that either by the timing of your foods. I know you've had episodes on this previously, maybe eating protein with your foods. There are other things that you can do to decrease the size of that blood sugar spike. And for some people, that may be beneficial. The problem is that it's really difficult to predict what foods will do that. 10 years ago, you would have talked about the glycemic index, right? So this is a food, it has a high glycemic index. That means when you eat it, you're going to get big spike in blood sugar. What we've learned in the last 5 years is that just doesn't hold from person to person, right? You can have two people eat the identical foods, and one person will get a big blood sugar spike and the other person won't get any spike at all. And then there's a recent study, it came out, it's a preprint, so it's not formally published yet. It will come out soon as by Kevin Hall, who's done all these very complex metabolic ward studies in the US. And they had these trials where they gave people a fixed menu, and they had a plant-based one, they had a low-fat one, a low-carb one, and the menu would cycle over a couple of weeks. So they would have, and then some of the people in these trials wore continuous glucose monitors, and then because the menu rotated, they would get a blood sugar response to the same meal in the same person, but a week or two apart. And what they found was that eating the same meal in the same person resulted in completely different blood sugar responses from one week to the next, which just tells us that we have, like right now, we cannot predict what foods will spike our blood sugar. So even if we have our own, I see you're wearing a continuous glucose monitor, that you have to test something out a lot. Yeah. Again and again in yourself to see an effect. And even then, there's going to be a lot of variability. So then is that even meaningful or feasible for some people? It becomes really difficult. So I think like managing blood sugar is obviously incredibly important, but right now it's just really tricky to navigate. And there's, Tim Spector's done some recent studies where they show that a whole bunch of things affect how you respond. So it's, how did you sleep? What meal of the day is it? Like, what's your genetics? Like, have you exercised recently? There's a whole bunch of things that affect how you respond to foods. And even in the same person, the same meal has different effects from one week to the next. So,
but I think that speaks to what you said, maybe when we were talking about alcohol or caffeine, that in a biological system, it's very rarely just one thing, right? It's because you're assuming that everything else in that system is identical when it isn't. And we're not the same person day to day. We, anyone who has worn a continuous sugar monitor, and I think for some people, it can be tricky to figure out, well, what does this actually mean for me? I feel I'm quite in tune with my body, and I guess it's what I do. And I think about this and sort of pay attention a lot. And I certainly found for me that you can see correlations quite well where, depending on if you haven't slept well, your sugar's higher, and the same meal can give you a bigger response. Or if I feel high levels of stress, I guess with everything we're talking about, we've done alcohol, caffeine, sugar, a bit on ultra-processed food so far as well. Are we not more and more moving into an N=1 era whereby we can use science to give us good starting points and ideas, but ultimately we're going to have to test these things out on ourselves and go, well, is this working for me?
I think so. And that's, even going back say 50 years, this is in a slightly different arena, but looking at elimination diets were once the gold standard for people with certain autoimmune conditions before we invented monoclonal antibodies for these things. And the only way to know if they worked was to, change your diet and see how the patient responded. And you would do that individually. And I think that's where we really are at this point. That the problem is that, so say, if we go back to blood sugar, or we stay on blood sugar, I'm not convinced that the data is necessarily helpful for people. So say I don't generally recommend that people go out and get a blood sugar monitor. And one of the reasons is that it becomes, and I've seen this several times when working with people, it becomes incredibly stressful. So I'm going to eat a piece of cake. I know that cake is going to spike my blood sugar. I'm now stressed about the blood sugar spike that I'm going to see because of the cake that I'm eating. And we've had people who've come back and just, we didn't really appreciate how much stress, like the idea of eating and how that was going to affect the data that they see was incredibly stressful to them. So, like, is that, at what point does that become harmful? And there are actually studies that show that the expectation of a blood sugar spike drives a bigger blood sugar spike. So there was a study by Ellen Langer at Harvard where they took diabetics and they gave them a milkshake and they showed them how much sugar was in this milkshake. There was a high sugar milkshake and they saw a big blood sugar spike. And then later on, they came back and they gave them a different milkshake. It was a low sugar milkshake and they showed them that and they had a lower blood sugar spike. It was the same milkshake both times, but they had a bigger blood sugar spike when they thought that it had more sugar in it.
Biology and psychology.
Yeah, biology and psychology coming together. So I think that, yes, the N=1 experiment is really important, but I think that rather than like being hyper-focused on this one thing, which is blood sugar, can you move yourself closer to a less processed diet, right? Increase vegetable consumption, right? So make vegetables a bigger part of your plate, or start with a bigger portion of protein on your plate, right? That's going to come with both of those. Going to come with a whole bunch of nutrients and these other things, and then maybe decrease the portion of whatever it is, is it refined carbohydrates or something. So I think that overall shifting your dietary pattern is much more important, and that doesn't need necessarily, unless there are different foods that you enjoy, as much N=1 experimentation. So I think we're at a point where you can, particularly with diet, you can give pretty good advice that's going to work for a lot of people, and they don't need fancy tools and they don't need fancy data, and they can still make a big impact on their health.
Yeah, I appreciate your perspective on that. And I've always had a real caution with trackers. I guess the argument you're making around CGMs, continuous glucose monitors, I guess we could also make about, let's say, scales, for example, and weights. And I kind of feel a lot of this becomes personality dependent, whereby for some people, scales and their weight becomes incredibly obsessive and becomes problematic. And then for others, it's like, they can check once a week and, I'm going in the right direction. I've mentioned, I think before with you, that I saw the same thing with blood pressure monitors, which aren't like modern tech necessarily, but God, for half the patients, it was great. For the other half, it was anxiety inducing.
Yeah.
I guess where I see CGMs as being different is I kind of feel that they give and I totally agree they can be overdone. I think if you've got a history of eating disorders, you've got to be very cautious. It's probably not the right approach for you. But in the context of a population, as we say, maybe 60, 70% in the UK, maybe 90% in the US, of the population having a degree of metabolic dysfunction, I think in that context, I personally believe we have to be open to tools that are going to help people, because we've been asking people to make these choices for years. And I feel that we're still struggling. And a lot of that's because of our food environment, I know. But I don't think I've seen a better tool, Tommy, in over 2 decades of practice now, where I don't think I've seen a better tool that helps people start to change their diet in a meaningful way than a CGM. I don't think everyone needs them. But I would say from my own experience with people and also myself, I found them to also to be very, very helpful. So that would be what I would say in response. So I think we have maybe a slightly different perspective on this, which is okay as well.
Yeah, absolutely. And there are studies in type 2 diabetics that, and again, early small studies suggesting that having a CGM improves their adherence to, say, a dietary intervention or dietary recommendation. So absolutely, sometimes that can, give people some accountability and help drive some behavior change.
And it's with let's say a step count on your watch or your phone. For some people, it works great and it motivates them. Like, I didn't get my 7,000 today. 7,000 my target. So I'm only at 5,000. After dinner, I'm going to go for a walk around the block. But for other people, it becomes an obsession and problematic. So I think, again, relaying this to alcohol and caffeine and sugar, I'd say I think it depends a lot. And I do think we can overdo these things. And I do, as I think I mentioned last time, I did wear an Oura ring a few years ago, but I haven't worn one in years now because I kind of learned what I needed.
Yeah.
I get it. If I eat near bedtime, sleep quality goes down. Okay, great. If I saw a few other things and I don't really feel I need it anymore. I learned what I did. And I kind of feel for some people, like you wear a CGM once for 2 weeks and you have your regular foods and you're like, I had no idea that does that to me. And no idea. I think for some people, that's all they ever need.
Yeah.
So yeah, this will be continued, I'm sure, as we see this evolve over the coming years. I think that the common view in society is that as we get older, our brain function has to decline. What's your view?
I think that it's true that it does on average. And you can see that multiple large population studies show that pretty much every cognitive function that you can measure decreases fairly linearly over time, except for memory about the good old days. The majority of people seem to be able to remember the good old days, but every other, the executive function, short-term memory, all these other functions decline over time. However, I don't think it needs to be that way. Part of what I find to be very interesting about cognitive function and the way we think about it when we age is that there's this story that says you're born with some, like X number of brain cells, and then like every time you maybe drink a little bit too much or you don't sleep, you're killing brain cells, and it's just this inexorable decline that you can't change. And that's not true. We can make new brain cells in some areas of the brain, particularly in some areas of the hippocampus, which is associated with memory. But even then, even if you're not making new cells, the cells you have can make new connections. You can change the structure around those cells in the brain, which is what helps support their function. And you can see that in multiple studies. Even as people get older, you give them a new challenge of some kind, you challenge their brain, and then they'll make new connections. Those areas of the brains will get bigger. You can see it on an MRI scan. So what I find interesting is that just like the muscles of your body, which is easier to think about because you can visibly see it. If you train it, it gets bigger. You can see strength much more easily. But the brain is very similar. If you challenge it and you ask it to do new things, it can adapt pretty much any time in life. So part of it is getting over this thought that, I'm old, my brain doesn't work anymore, there's nothing I can do about it. So stop telling ourselves that story and then introducing things to ask more of your brain, and then it will function better.
That's really empowering for us to realize that there are actually things that we can do. We're definitely going to get super practical and talk about a lot of those things. You mentioned that there are studies showing that various functions of cognition, various functions of our brain do start to go down with age. These studies that have been done, when have they been done? Because we know that there's a poor level of background health in the population, metabolic health, cognitive health, all kinds of things that generally society is pretty unhealthy now in many ways. So therefore, are we just studying a sick society and seeing cognitive decline go down? Or is it something that's actually an inevitable part of aging, in your view?
So until we get to the point where we can completely stop the aging process, which I think is unlikely to happen anytime soon, function will decline over time in anybody. When you like how long that takes and what sort of the ultimate end of that.
Sorry to interrupt. If you're enjoying this video and want to dive deeper into the topic of nutrition, I have created a free special guide which contains the 5 most important changes I think we all need to make when it comes to our diet. If you want to get hold of this free guide, all you have to do is click on the link in the description box below.
I think is modifiable and very much so. So there is going to be a decline over time, but you can change the trajectory quite dramatically. So that's where you end up. But when you ask about how these studies are done, I guess there's 2 different ways. One is you do this large population observational study. So you look at the cognitive function in multiple people of different ages. And then you kind of see that across ages, as you look at older people, their cognitive function declines. You can do that in large populations. In a smaller population, you might be able to take the same people and look at their cognitive function over time, or look at their future risk of dementia, and that's been done too. However, when you're studying the population, and in general, these are studies done in modern, westernized, industrialized populations, and we're at a stage where we have to say that those populations are, on average, unhealthy. The vast majority have at least one of the components of metabolic syndrome. They, on average, take 1 prescription medication, on average have at least 1 chronic health condition. So we know those various things, that poor systemic health is associated with worse brain health and an increased risk of cognitive decline. So you're right, it's very difficult to study very healthy people and look at what happens to their brains, because there just aren't very many of those people to study anymore.
When we think about cognitive function, a lot of people are thinking about Alzheimer's.
Yeah.
They're thinking about, I don't want to get Alzheimer's when I get older. Maybe they've got a parent or, an auntie or a grandparent. It is affecting many people's lives these days. They're seeing what happens. So I wonder if you could explain, first of all, what is Alzheimer's? And just compare that to cognitive function, because declining cognitive function, so declining brain function as we get older, is not necessarily the same as Alzheimer's, is it?
What we call Alzheimer's disease is essentially 2 different diseases in my mind. The original Alzheimer's disease, as described by Dr. Alois Alzheimer, is what we would now call early onset or familial Alzheimer's disease. It's caused by a single mutation in a single gene. There are a few genes that you could have a mutation in, but you just need a mutation in one gene that causes early dementia, like 30s or 50s. So 3rd to 5th decade of life, and has sort of like a steady decline and quite rapid. And
that's a huge genetic component.
It's almost all genetic,
okay,
and it's less than 5% of cases of Alzheimer's disease. So it's fairly rare, relatively. What most people think about when they think about Alzheimer's disease is what we might call sporadic or late onset Alzheimer's disease. It maybe occurs in your 60s to 80s or later if you live longer. And it's very heterogeneous. It's very variable from person to person. There's this old adage that says that if you've seen one person with Alzheimer's, you've seen one person with Alzheimer's, because it's like how it expresses itself in different people is very different based on their environment, their genetics, their lifestyle, their general health. And that second disease, I don't think is Alzheimer's disease as he originally described it. They're very different, and you can look at them completely separately. So that we might call, or I have called in a paper that I published with a colleague of mine recently, age-related dementia. And it's influenced by all the things that we just mentioned, and we could talk about that more. As you go into that, there is this period of cognitive decline. So clinically, you might call it mild cognitive impairment as a specific diagnosis. And again, it's sort of like the prodromal period before frank dementia sets in. But everything happens on a continuum. So if you look at cognitive function over the lifespan, like I said, it sort of from your 20s or 30s, it on average steadily decreases. So these processes are starting much earlier in life, and that's been described. These processes of maybe the so the brain atrophying, starting to lose cells, but also measurable changes in function. Some of these things you can see on scans. It might start very early, but it takes a long period. It takes a long time before you get to the point where your actual function is detectably decreased, if that makes sense.
Yeah.
And the way I again liken it to physical function, because again, I think that's something that people can picture more easily. So if you imagine that whatever you're able to lift, say, on a daily basis, shopping bags, things like that, you can probably lift more than that, right? You have this headroom, what you have to do every day versus what you would be capable of doing. However, as function declines, eventually your maximum capacity is what you're able to do every day. And that's what we would call frailty, physical frailty, because you have no capacity for, so say if you stumble, you can't save yourself, right? You're going to fall over. Or if we're thinking about leg strength, your leg strength will decline to a point where getting up from a chair is as much as you can do, right? You have no headroom. And so that's what happens with cognitive frailty or cognitive decline. You just don't have any extra capacity. The brain can't do any more than you're asking of it every day. And eventually you get to the point where the function isn't good enough to do your daily tasks. And then that's when you start to go down into dementia.
Yeah, super helpful and really, really clear. So as we progress this conversation, let's be really clear that when we're talking about, Alzheimer's, we're not talking about the early onset, the classic Alzheimer's. We're mostly going to be talking about age-related dementia. This, I think, is what many people are quite scared about.
Yeah.
Certainly the older people get. And it's not uncommon now in people's 30s or 40s, man, I can't remember stuff like I used to, right? So I think everyone is aware of the kind of phenomena we're talking about. Let's say people get a diagnosis in their 60s. When does it actually start in their brain?
So it probably starts right after your brain finishes developing. So after you've built the brain, you've built the connections, you've put down the final parts of white matter in your prefrontal cortex that maybe happen in your 20s or mid-20s, early 30s. That's when the decline starts. So you increase, you build the brain, you increase its function, and then it starts to decline. I don't mean that in a negative way. That is just when the process starts. And part of that, I think, is driven by societal pressures rather than some process that we have no control over.
Yeah.
And what I mean by that is to try and think about what a brain needs to maintain its function, because I'm a neonatal neuroscientist. That's my day job. So I think about what does it take to build a brain in the first place? And obviously you need, the actual structure. So you need the nutrients and the fats and the things that make up your brain. But you also need the kind of stimulus that it takes to build connections. And so think about babies and toddlers. They're continuously exploring, trying new things, failing, building motor skills, right? Tripping over, trying to stand, trying to climb trees. But they do the same with language. They do the same with social skills. They're constantly pushing themselves, trying new things. And sometimes they fail. But, they laugh it off and they just keep going. And then they do that for a period of time and then they sleep. They rest and recover. They need that for what we call consolidation in the brain, for that period of plasticity where you're sort of building new connections. Adults don't do that.
Yeah.
We do the same things again and again and again. And part of what I think happens in your 20s and 30s is that you leave formal education. You leave that period of trying new things, learning new things, learning how to drive. All of that's done. And then you become increasingly good at the things that you do every day, which isn't stimulating your brain in the same way.
Yeah.
So I think we can build those things back in. But part of the reason why that decline happens at that period of time is because that's the time when you stop challenging your brain to develop new connections and to maintain the structure that it has.
Yeah, I mean, it's so beautifully simple the way you look at that when you look at kids.
Yeah.
Trying new things, they're failing, they're exploring, they're experimenting, and then they sleep.
Yeah.
Right. So giving it the stimulus, you're giving it that new information so the brain adapts, and then you're resting so it can grow stronger.
Yeah.
And yeah, as adults, certainly as adults in the current society in which we live, we don't tend to do that. It's really interesting, Tommy, as you were talking, and you were saying that cognitive decline, that decline in brain function probably starts somewhere around our early 30s. And before you were talking about how our brain mirrors our muscle, well, we know that from the age of 30, we start to lose lean muscle mass unless we do something about it. So there really is a very strong similarity, isn't there, between muscles and brain?
The more I think about this and look at this from the societal down to the biochemical level, I think they mirror one another almost exactly. And it's the same with almost any tissue in the body. In particular, the thing about muscle tissue in the brain, it's very easy to draw lines across them, which is that the structure and function of a tissue is directly proportional to the demands you put on it, right? The more you challenge your muscle, the more muscle you grow. But in order to grow, you need a period of rest and recovery. And the brain is exactly the same. And you can think about that in terms of building new connections, building new cells, but also processes of repair. So autophagy is this thing that people are really interested in now, where you start to break down the accumulation of damaged proteins and other things within cells. And in muscle tissue, the best thing to do if you want to increase autophagy in muscle tissue is you exercise it, you move it. And it seems that the brain is the same, that stimulating the brain is protective because it upregulates these repair processes. And so that then gives you this framework where you say, well, in order to improve the function and structure of my brain, I need to challenge it. But then I also need to give it everything that it needs in order to adapt to that challenge. So that can be nutrients, it can be sleep and recovery, it can be making sure that there aren't toxins in your environment. Like we know air pollution is linked to an increased risk of dementia, things like that, which then may inhibit your ability to adapt. But the primary driver, in my mind, really seems to be like, how much are we asking of our brains and how much are we allowing it to recover? And that brings in a part of things around health equity, because not everybody gets to sleep. People working multiple jobs with, or lots of family members in a small space, it's very difficult to sleep. Or being chronically exposed to societal stresses, and that chronic stress is probably something that prevents adaptation because you don't get a recovery period. So you can start to see how all the things that we know are linked to an increased risk of dementia may be linked to, first of all, how much are we challenging our brains, and then how are we supporting it in its ability to then adapt to that challenge.
I want to get to the practical things we can do shortly. Earlier today, I spoke to Tim Peake, British astronaut. He spent 6 months on the International Space Station. And there's a couple of things in that conversation that I think really speak to what you have been speaking about. He spoke about the training process. He had 6 years of training. Now, in that training, there's all kinds of things they do. They put them in super uncomfortable situations. They're really trying to build physical resilience, psychological resilience. They take them to cold, dark caves. They deprive them of time. They see what happens when you are under that much pressure. So they're being pushed out of their comfort zone to see how they respond. But he also had to learn Russian. Now, I don't know how old Tim was, but that's interesting based on what you have said, right? Because I'm thinking, yes, he's being trained to be an astronaut. So, teamwork, be resilient, deal with pressure. But actually, a lot of that training is also going to reduce the likelihood that he's going to get age-related dementia. What would you say to that?
I'm sure that's the case. Other than the fact that microgravity or lack of gravity
I was thinking that as I said the question. Otherwise,
has an interesting effect, at least on muscle tissue. And so how it affects the brain would be an interesting thing. But in general, from his time on Earth, yes, all of those things.
Had he done the training and not gone to space, then that would be excellent brain training.
Yeah.
But again, learning Russian, like we tend to learn languages at school because we have to.
Yeah.
But That new paper you published, which was wonderful, like it's such a good paper, and we'll definitely link to it in the show notes so people can read it themselves. You made a very strong case with your, I think, co-authors, that a lack of stimulus to our brain may well be causative, so not associated with, but causative of this age-related decline in brain function.
So that's certainly how I read the literature. And so I published this paper with Dr. Josh Turknett, who's a neurologist. And it's difficult to really unpick causation in humans to say you've really proven it. And in fact, it's impossible to prove anything in biology. I think that, people need to appreciate that. However, if you look across a broad range of animal studies, human studies, that's really, again, how it looks. And it comes down to how much you're challenging your brain and then supporting your ability to adapt to it. So it's not the only thing, but again, to draw a connection back to muscle tissue, imagine you had the perfect diet and plenty of sleep and strong social connections, all these things that we know are supportive of health. But you didn't do any exercise. You were sort of confined to your bed. And there's been hundreds of studies done on bed rest or immobilizing a limb. If you've broken your ankle and then you put your leg in a cast, when you take that cast off, the muscles on that leg have gotten smaller. Or if you lay in a bed and you don't move, your muscles get smaller. So even if everything else is perfect, if you don't stimulate that tissue, it will reduce in both size and function. And the brain seems to be the same. I think one of the most interesting lines of evidence that supports that idea is based around retirement. There are multiple studies in multiple populations that suggest that the earlier you retire, the earlier you get cognitive decline and dementia. And this is particularly in people who have cognitively stimulating jobs. In fact, then the effect is bigger there. Mm-hmm. And this is after you adjust for, you might retire early because you have a medical condition that's also associated with cognitive decline. This is after you adjust for those things. You see this sort of rapid decline in cognitive function when people retire. And that's because work is the thing that's most cognitively stimulating for most people. And then you remove that and you don't replace it with other stimulus. That's when you start to see the sort of inexorable or sort of faster decline in cognitive function.
So for people listening, right, Tommy, who either have retired themselves or are thinking about their parents, or we have a lot of younger listeners these days who might be thinking about their grandparents, based upon that, they've retired, they've left their job. So what practical advice would you give to them as to how they can sort of make up for that lack of cognitive stimulus?
So what's nice about this is that it seems that there are many different ways to overcome this, all of which are very likely to be effective. So you alluded to one of them, which is learning a language. And learning languages, even late in life, have been shown to improve cognitive function and be protective for certain areas of the brain. Physical movement does it. Resistance, there are randomized controlled trials that show that resistance training improves the structure and function of certain areas of the brain. So just going and starting to lift something if you've never done that before. With respect to movement, it seems that you get more benefit if you do a movement that has some kind of coordination component. So you might think Tai Chi or yoga. One of the modalities that's best researched is dancing. So if you have older adults in their 60s and 70s and you make them do some kind of circuit training at the gym, or the same amount of effort of activity but in a dance class instead, they'll get more cognitive benefit from the dancing. And actually, you can even see that on an MRI scan. Their hippocampus gets bigger more than the other group. And what's nice about something like dancing is that there's a music component, there's a social component, there's a movement component. All of these things we know support health, both physically and mentally.
So all of those things, I understand in isolation would be helpful. Music, social connectivity, very, very good for the brain, physical movement. All these things individually, I think, have benefits, but you chuck all three together and mix them up at the same time, then it's almost like a three-dimensional stimulus for the brain rather than just a one-dimensional one.
Yeah, exactly. And there is some specificity in terms of what are you asking your brain to do versus what does it get better at. So when they've done studies of individuals that did a very challenging learning stimulus. The best example that I know of is taxi drivers who are learning the knowledge in London. So they took three groups, or they ended up with three groups of individuals. So for those who don't know, I guess people don't need to learn the knowledge anymore, but it's 25,000 streets, a six mile radius around Charing Cross station in London. You have to learn to be a taxi driver in London. So it's a huge amount of things you have to, like, I mean, just the memory component is incredible. And it took 2 years. So people they did brain scans before and after. And those who learned the knowledge and passed, they saw an increase in the size and some measures of intensity of connection of the hippocampus, which is the area related to memory in the brain. And these are adults in their 30s and 40s. Those who didn't manage to pass didn't see that, and then also they had a control group where they didn't see any change. So this is specifically in those people who managed to do this huge learning task, saw benefits in that area of the brain. But then they saw a slight decrease in some other aspects of cognitive function because they put so much into memory. So if you really focus on one thing, you become really good at it, but then maybe you've taken away some things from other areas of the brain. It's possible. So if you take something that gives you all of those at the same time, so you mentioned like social connection, the benefits of physical activity, plus the coordination component, plus music, I think there's multiple aspects of stimulus, so it's multiple parts of the brain, but they seem to come together in a way it's difficult to say if it's true synergy, which is that it's more than the sum of its parts, but definitely seems to be more beneficial than doing any of those things individually.
There's a lot of talk in the longevity space about the optimal amount of protein that you need for your muscle mass, which is important for longevity. And I don't disagree that muscle mass is important for longevity. There's also advocates for low protein diets. And I think this is one of those areas where there's a lot of debate about, and I think it leaves people feeling confused. So how do you view protein, and what kind of recommendations do you make to the people that you see?
I generally think that people undereat protein at the population level. And part of that is driven by the types of foods that they eat, which tend to be low protein.
Could you just explain population level?
Yeah,
in case
so
people don't get it.
Yeah, so if you're going to look at how people eat in the US or the UK on average, so that's the population level. How much protein are they eating? And in general, I think people eat too little, particularly as they get older. When you look at some of the evidence around protein intake and longevity, there's two broad streams of evidence. One is animal data. A lot of it's from mice. And I mentioned this last time I was on the podcast. I do animal research for a living. That's what pays the bills. And most animal research is not useful for humans at all. I think most of it's a complete waste of time. And I would include most dietary studies in rodents, if I'm honest, because rodents are not small humans. And we have seen again and again how these kinds of studies fail to translate to humans. So if you feed a mouse, which doesn't normally eat a high protein diet, you may see some negative effects on their health. But that doesn't necessarily, that tells you that you shouldn't feed mice a bunch of protein. It doesn't tell you whether you should feed humans more protein. And humans evolutionarily consumed a lot more protein. Like, in addition to being gatherers, we were hunters, and it made up, like, animal protein made up a large proportion of our diet. And our digestive system and our metabolism is in tune with that. And, you know, that, I think that's an important consideration. Like, what are we looking at to try and tell us some of this? The other type of information or studies that we get are usually epidemiological studies. So we ask people how they eat, and then we look at how long they live or what diseases they get later on. There are two problems with that. One is that people are really bad at telling us how they eat. So there's one classic study on protein and cancer and longevity, came out in Cell Metabolism nearly 10 years ago. And they talked about how low protein was beneficial early in life, and then higher protein was beneficial later in life. And they used, there was some mouse data, and then there was some human data, and they used a study called NHANES, the National Health and Nutrition Examination Survey in the US, where they call up a few thousand people every year, and they say, what did you eat in the last 24 hours? And then they say, so you tell them, and then they're like, are you sure you didn't have any ice cream? Are you sure you didn't have a beer? Right? So like things that people just tend to underreport. And then that's it. That is then assumed to be their diet every day. And they also ask them how typical it was, right? For their diet. And then they look at how long they live 20 years later. And there have been some studies on NHANES data in particular. There was a nice paper that came out that said that the majority of dietary responses in NHANES were not physiologically plausible, as in these people, based on how tall they are, how much they weigh, their physical activity levels, what they've told us they eat cannot physically be correct. It is physiologically implausible that they're eating this amount. And we're using the protein intake from that study to say, this is how, this is how protein affects your health. In reality, we have no idea what these people are eating. So a lot of the data that comes from that is being used to make recommendations, particularly to eat low protein, is just so highly flawed that I just wouldn't even look at it. It's not even worth considering. So then you might think about, what about some interventional data, right? We have people and we change the amount of protein that they eat, and then we look at some outcomes.
Can you just explain interventional data as well?
So interventional means that there's some people who come in for a study and we physically change something, and then we track responses over time, rather than just asking somebody what they eat and then assuming that it's correct and looking at the long-term outcomes. And particularly as individuals get older, we know from interventional studies where we have looked at them and we've fixed the amount of protein that they eat, or increased the amount of protein they eat, and then we look at their outcomes, that as you get older, in order to maintain muscle mass and strength, particularly strength, which is a critical component of long-term health, older people need more protein. And in general, as we get older, we tend to eat less protein. We tend often hunger decreases, and the protein is very satiating, and so the protein intake decreases over time. So not only do we eat less, we also need more relatively. And so in general, I think particularly as people get older, they have a relative protein deficiency, and that affects a whole bunch of things, right? That affects gut function because you have a high turnover of cells in your gut. You need protein to replenish those. It affects muscle function, probably cognitive function. The amino acids are really important for neurotransmitters and all these other things. So in general, I think most people undereat protein. And there have been studies where they give people vast amounts of protein and see almost no negative effects on their health, like 4 grams per kilo. So it'd be me like eating 400 grams of protein. That's a heroic amount. It's a huge amount of protein. I would never eat that much protein.
Heroic.
Yeah. But in these studies, they're eating that for a year or two. It has no negative effects on any blood markers or anything.
What about these rumors that high protein diets are problematic for our kidneys? Where does that come from?
So one of the things is that if you overeat protein above your requirements, your kidneys will have to work harder to excrete the extra nitrogen, which is from that. But that's part of what the kidneys do. That's part of their job. In people who have normal kidney function, so if you have chronic kidney disease or you're on the way to or need dialysis, it's a completely different question, right?
For sure.
You absolutely speak to your renal team. That's the important thing you need to do. But for people with normal healthy kidneys, eating, there's no negative effect of protein intake on kidney function. I'm not actually entirely sure where that originally came from, but there's really no evidence to support that.
I really appreciate that. Whenever I come across conflicting bits of information, or let's say different health experts giving advice on the same topic, but completely different bits of advice, which again is one of the reasons I wanted to have this conversation, because I think there is a lot of confusion where people go, wait a minute, this expert who I really like and respect said this other expert who's also a medical doctor or also a scientist or a researcher said the complete opposite. I don't know what to do anymore. The way I look at that often is I I go and trust what I've seen time and time again with patients, right? It's because, as you said before, you can actually find a lot of science to support both sides often of an argument, which gets really, really confusing. Sorry to interrupt. If you're enjoying this video and you want to learn more, then do check out my free special guide, which contains the 6 crucial steps you need to take in your life to not only build healthy habits, but also to make them stick. If you want to get hold of this free guide, all you have to do is click on the link in the description box below. But what I know is that I have seen I've seen tens of thousands of patients, and I've been applying these lifestyle principles for many, many years. And whilst I would always say there's very rarely one approach that works for everyone, there are some common principles that I've seen work time and time again. One of them being, in this modern food environment, I think that also comes into it, right? When and where are we studying people? In the context of a food environment which is highly problematic and full of ultra-processed foods everywhere we go, encouraging us to eat too much and for too long a period over 24 hours, I've found, honestly, that increasing our protein intake for many people really helps them get back on track.
Yeah.
It helps them feel fuller. It helps them eat less overall. And so I guess my bias would be that I've seen that work over and over again.
Yeah.
So for me, it's a helpful recommendation. I think most people benefit from a bit more. But then what does that mean? Because you will hear things like, some people say 1.8 grams of protein per kilo.
That's more. I think that's more than you need.
I do, because if I apply that to myself, right, I'm almost 6'7". I weigh, I don't know, I really don't weigh myself, but I'm probably somewhere between 95 and 100 kilos. So let's call it 100 kilos for simple maths. That's like 180 grams of protein a day. I think that feels pretty heroic as well, right? That's a lot of protein. Now, you may say, actually, for your height and frame, that's fine. But, I never really like getting into, grams per kilo. But I do accept for some people it's helpful. Do you have a recommendation about that?
So I think the general recommendation, and there's been lots of different meta-analyses and these other things that look at how well do you respond in terms of, and again, like muscle mass and strength. I think those are a nice hard outcome that we know are associated with long-term health outcomes. At the same time, not seeing any negative effects. And in general, it is probably somewhere around 1.2 to 1.5 grams per kilo, say. There was a meta-analysis that looked at strength responses in younger and older individuals, and the optimal amount of protein intake from, again, interventional studies seems to be about 1.5. But there have been other studies that compared like 1.3 to 1.7, and they see similar responses. So it's somewhere in that kind of range. And in general, what that means is that if you have 3 or 4 meals a day, or 3 or more periods of where you intake some calories, that each of those contains something like 20 to or 30 to 40 grams of protein. And you can figure out what that looks like in terms of a cut of steak or salmon or eggs or tofu or yogurt. There's some strained Greek yogurts that have a high protein content. And and I think that's how you should, in the way that I would work with people, is that's the basis of the meal. Like, that comes first, and then things come around, because that's probably going to be the most critical single component that you want to consistently make sure you're consuming, because the fats and the carbs and things, they can kind of go up and down and around. But I think the protein, I would recommend, be relatively consistent and in that range. And relative to what you mentioned earlier, as I say, there was another study by Kevin Hall that I mentioned earlier, where they had people consume either an ultra processed versus a minimally processed diet, and they have them in the lab, and they can eat as much as they want, and they measure all everything that they eat, and they can follow them for several weeks at a time. And even though they matched for like fiber and these other things in the diets, those who were eating ultra processed foods, and it was, if you look at it, it's just like cereal, sandwiches, bread, right? Just typical.
That's the standard diet for many people.
Standard diet. those individuals on that diet ate about 500 calories more on average per day, 400 to 500 calories more per day. But the protein was consistent in the two diets. So the idea is, it comes to this idea of something called the protein leverage hypothesis, which is that you continue eating until you reach a certain protein threshold that your body needs. And so most, like I said, ultra processed foods are low in protein. And part of what's driving you to eat more of them is to get up to some protein requirement. So an easy way to get around that is to make protein the focus of a meal, and then you will be more satiated and you're less likely to overeat in response.
There are some proponents, I think, of having a minimum of 30 grams of protein, particularly after, let's say, an overnight fast. I think someone like Gabrielle Lyon, for example, or Don Layman would promote a minimum of 30 grams to make sure you're getting the minimum requirement of leucine that's needed to build muscle.
Yeah.
You mentioned before, I think, 20 to 40 grams. And
the 20 being, there are some people who are a lot smaller than you or I, so 20 would be just fine. So that's where that range starts to come into play.
Fine. So 20 to 40 grams, basically, you're saying should be the mainstay of most people's meals, and that will depend whether you're slight or whether, if you're very tall and large. Well, if you're very tall like me, it's probably going to be more towards 40 grams.
Yes.
Okay. So helpful. And I also love what you said before, that there really isn't that much evidence that high protein diets, if you have too much, you're not really causing harm. No. Your kidneys will just have to get rid of it.
Yeah.
Fine. Well, let's just talk about exercise and movement. I think there is a lot of confusion about exercise. What's the state of play? Okay, we have a sedentary population, right, who are not moving enough. There's a lot of talk these days about different types of exercise, different zones of exercise. There's talk of HIIT training, high intensity training, walking. And then, I talk about it as different gears of movement. So gear 1 might be walking around the block. Gear 2, very much equating to your car, you're going a little bit faster perhaps. And there's a lot of talk about the unique benefits of what is being called zone 2 training. And some of the advice around that, I think, is going to be very unachievable for many people. So let's try and break it down. What's your current perspective on movement and what we all should be doing?
I think I said something like this last time, and I still feel the same, which is that whatever you can do that's more than what you're currently doing is great. Until you get to the very, and then I remember some comments of people going in like, oh no, people shouldn't lift weights because they're going to get injured. Well, actually, lifting weights in like a bodybuilding style is one of the safest forms of exercise you can do in terms of injury risk. And then some people said, oh yes, but you can get to a point where you're doing so much exercise that it's detrimental. And yes, of course that's the case, but like, I'm not talking about people exercising 30 hours a week, right? I'm talking about somebody going for a walk for 20 minutes a day. And so whatever you can do sustainably above what you're currently doing or previously have done will benefit your health. And I think, that could be steps per day. It could be, amount of time you spend going for a jog or cycling or lifting weights or any kind of resistance training or anything like that. So if you look at, say, the amount of physical activity that significantly improves certain health outcomes. So, me, I often think about the brain. So the amount of physical activity that significantly improves cognitive function, been large meta-analyses that have looked at this, is basically, it doesn't matter exactly what type you do, but if you're achieving, say, government physical activity guidelines, which is 150 minutes per week of moderate to vigorous physical activity, that is associated with a statistically significant improvement in cognitive function. And you can break that up however you like. You could do 30 minutes of brisk walking a day. You could do 20 minutes of Pilates a day. You could do 30 minutes of resistance training a day. You could do 5 minutes of sprinting per day. The way that it works in general, at the simplest level, is intensity times time. So the more intense, the less time you need. The less intense, the more time you need. So you can, like, one day you can go do a little bit of sprinting in the park if you want, or you can go for a brisk walk, or you could do an hour of gardening, right? That's even less intense, but even that's going to have some benefits. So incrementally improving this sort of intensity times time, this volume that you're doing in any of those activities is going to be beneficial. And like that's honestly where I start. And if you want to then dig into resistance training versus endurance training, all those other things, we can do that. But the most important thing is that you do some movement every day. And if you're sedentary right now, literally anything that you can get up and do is going to be beneficial.
Okay, that's really useful and really empowering, I think, for people. What you said about intensity there is really, really interesting. So by what measurement or through what lens are you saying that 1 hour's gardening might be equivalent to 5 minutes of sprinting? Because we could probably measure that in a multitude of different ways or look at various aspects of that to try and compare them. How are you comparing them when you say that they're the same?
So in general, when that's done, they use something called the metabolic equivalent, or MET. Yeah. And you can Google, there's a PDF of METs for different activities, and it's very long. Like literally every intensity of pretty much any activity you could think of, it gives you an average MET. And of course, that's, if I go sprinting, it's a very different number of METs than if you go sprinting, but it just gives you an idea of the overall intensity of that activity. And so then if I think about the cognitive function study, what they looked at was how many MET minutes per week. So again, that's intensity times time. Do you need to do per week to see a significant improvement in cognitive function? And it was about 700, which then, with a little bit of back of the envelope calculation, is about the physical activity, general government physical activity guidelines. So that's how, and when you look at that kind of says that, overall, those are going to have equivalent benefits. And when you look at, say, harder outcomes like VO2 max, which is a measure of how efficient your cardiovascular system is, that's sort of the gold standard, then yes, there's probably some protocols that improve VO2 max a little bit better than others. But if you look across all the studies that have been done, in general, you see the same trend, that it's intensity times time. So if you do very intense work for a short period of time, that has a similar benefit to a less intense a period of exercise for a longer period of time. And again, this is, if we're just thinking about normal people trying to move and improve their health, I think that's really the main important principle that it would boil down to.
Could we take that to an extreme? Let's say there's someone listening who, for whatever reason, doesn't move much at all. They get to work, do their desk job all day, come home and sat down at home and struggles with motivation to move their bodies or time or whatever it might be. If they every day did 5 minutes of sprinting as hard as they could, let's say a few intervals, maybe, 20 seconds of sprinting, 40 seconds recovery walking, 20 seconds of sprinting, and they do that for 5 minutes. So that's a pretty intense workout. Yeah. Whereas someone else says, you know what, I'm going to go for an hour's walk every day, a nice gentle walk every day. And I know there's other benefits, nature, stress reduction, time away from your work. It gets really complex if we're trying to look at all those different things. But from a pure movement perspective on the body, are we saying through one lens, they're pretty similar?
Essentially, yes. Assuming that you find some way to match the total amount of work that those two people are doing, which you can through like a intensity times time lens. In general, I think they're both going to improve their health, and it's going to be really difficult to separate out one versus the other.
Yeah. It's really, really interesting and empowering for people. So that's a sedentary population, right? Where you're going, okay, anything is better than nothing. And you're going to get a huge improvement if you go from nothing to something. How society changes our behaviors. Smartphones, GPSs in our cars, right? So many people now have no real perception of where they're going if that sat nav is not on. So what do you think the consequences might be as we outsource more and more of our brain function to devices and technology?
I think, as the way that you describe it, there's clearly a possibility that it's going to be detrimental, right? We've offloaded all the things that our brain is really good at, that make, some of which make us uniquely human, and we've offloaded them. We no longer ask our brains to do those things. And if you don't ask a tissue to have a certain function, it will no longer have that function, right? It's the same with your cardiovascular function if you're running. So I think that's definitely something we need to consider. But there's also the possibility that with the sort of advent of new technology, we ask our brains to do different things and be good at different things. And that may also be just as good, right? So I noticed myself, because I have access to huge volumes of information. And for my job, I need to know huge volumes of information. And the majority of the time, I probably don't remember all of the things that I could possibly need to remember. And I notice that what I remember instead is where that information is, right? So I still have memory of important things, but I don't necessarily remember the exact fact, but I know where that fact is. So when I'm preparing to do a podcast, I'm like, I know I need this piece of information from this paper, and I know who wrote it, and I know where to find it, so I can go back and read it. So I'm still requiring memory, but just in a different way, which I think is probably not necessarily detrimental. It's just different.
Yeah, and I guess, thinking about what you said just before that if you are putting all your attention on learning the huge amount of roads and back roads around Charing Cross Station, that takes up so much of your cognitive reserve that you have less available for other stuff.
Yeah.
So yeah, sure, you're a great taxi driver, but maybe other areas of your brain have been neglected. I guess you could make the case with technology that, I don't know, let's say you're driving to a podcast to be a guest. Instead of using up your cognitive reserve on the way, trying to figure out where am I going, where's the street, actually, it can make it quite a stress-free experience if it's all working and things go smoothly, which means that you have more cognitive reserve for the important activity that you're about to do?
Yeah, I think so. There is more and more evidence that suggests that you don't burn more calories by thinking harder, but your brain doesn't require more or less total energy. But there certainly seems to be reserves of things like willpower and decision making and access to cognitively challenging things that you can probably only do for a short period of time before you need some rest and recovery. So if you're offloading difficult but more menial tasks to something else, that does give you greater capacity in theory to then apply that to other areas. We know that the brain does not multitask. As much as we like to think that we multitask, people don't multitask. When you task switch from one thing to another, you end up wasting a lot of time as you adapt from one task to the other. So if you're in some deep period of writing and you just stop to check your email, it will take several minutes when you switch back before you get back into the same flow of the writing that you were doing before. So being able to be more fully focused on one thing because you offload tasks, say to technology, I think could be very beneficial. And there were other tasks that maybe didn't exist 10 or 20 years ago or 50 years ago that now our brains are very good at. So recently somebody asked me about video games. And a lot of video games can involve, reactions, fine motor control, problem solving, all these things that we can sort of like be challenging our brains in a completely different way from how we might have done 100 years ago. But that doesn't mean it's not beneficial. I think that's very beneficial. It's just different.
Different. What's really interesting on that, I heard over the past few months, you may know better than me because I know you do some work with Formula One. I believe one of the current top drivers apparently was an avid video game player growing up. And actually, because of the way these cars are now controlled, hey, I'm no expert on this. This is just what I've heard from someone in Formula One, that actually there may well be a lot of transferable skills from your ability to handle a video game controller and your ability to drive a Formula One car.
Yeah. One of the reasons why I said earlier that to some degree, maybe the challenge doesn't matter. Like there's some specificity, but just increasing challenges on the brain may give you greater overall adaptability and function, is because we know that formal brain training, so like computerized brain training, which is used very frequently in adults with cognitive impairment or cognitive decline, because it's very easy to standardize, systematize, easy to track. So it's often implemented in clinical trials. If you do this sort of abstract online brain training games, it translates over to better working memory, executive function, and sort of things that you actually need in real life.
Yeah.
Right. You don't just get better at the game. You also get better. There are the things that transfer. So, of course, video games may be very similar to driving a Formula One car, but there is some, just overall challenge increases overall function, which then does sort of translate to other areas.
You mentioned the term executive function a couple of times in this conversation. Can you just elaborate exactly what that means?
In the simplest sense, the way I think about executive function is your capacity to make informed decisions about your behaviors in the moment generally. And it's more complex than that. Maybe people have heard the old stories where we learned about different areas of the brain based on either soldiers getting very specific damage to areas of the brain during war, or that, there's this very famous case where a guy got like a railway pylon that just like took out just his prefrontal cortex of his brain. And that guy, just said whatever he thought, and it was very vulgar and very impulsive. And executive function is essentially your ability to override those things. So like we all think stuff, and then there's a part of our brain that says, don't say that, right? It's a really bad idea for you to say that. Or, you sort of have these, everybody has intrusive thoughts occasionally. You're like, well, what would happen if I just jumped out the window right now, right? Like I've randomly had that thought. Right, but executive function is, no, you really should not do that. Yeah. So it's those things which require, and it happens just a fraction slower than like the impulse. And it's your ability to control that and then sort of have some control over your actions.
Yeah, so executive function is clearly a higher brain function that we would want to maintain. We don't want it to be declining.
Yeah.
As you were saying that, I was thinking, if you look around on social media these days, sometimes you see comments and I'm thinking, that's a public comment, don't you? Other people are seeing that. I mean, that's just like, well, I guess it's off topic, but is it? No, that's an element of executive function.
I think so. And I guess there's two parts to this, right? One is that, people talk about the anonymity of social media. You could just say stuff because there are no repercussions, right? Usually part of you deciding not to do something is because there's some social repercussion, which in general on social media, there isn't. The other part of it, which I read about, from Mark Manson, who's just one of my favorite pop psychologist, if you want to call him that, where he made the point that because of social media, you're exposed to the opinions of far more people than you would be otherwise, right? So 100 years ago, when you couldn't have online interactions with people you essentially don't know, you might have seen 10 people in a day, and you might have seen 100 people in a week. And some proportion of the population are probably people who are going to say things that you don't agree with or just aren't very nice, right? But on social media, you may be exposed to 1,000 or 10,000 people a day if you've got a lot of comments on social media. So part of it, I think, is directly in relation to how you might behave differently in social media rather than in person. And part of it is that you're exposed to so many more people that some of those people are just going to be unpleasant, and you're going to see that.
If we get back to that family member who's retired, and so you were suggesting certain things that they could do to maintain that cognitive stimulus to reduce the likelihood that they're going to get age-related dementia in the future. I know we touched briefly on this in our first conversation, but I think it's worth going into again, Tommy. It's not about mastery, is it? It's not about being an expert. In fact, in some ways, you're better off doing something that you're not very good at. That's one thing I wanted to talk about. And then I wanted to sort of almost go from there to something practical for people, because let's say we're trying to reduce the rate of decline in our brain function. Something that I've been thinking a lot about over the past couple of years, maybe influenced by our first conversation as well, if I'm honest, Tommy, is what am I doing in the next 5 years of my life, or in this decade of my life, that is different and new and something I couldn't do in the last decade? And I think about this, I have this thing inside me that at some point in the near future, I'm going to take up martial arts because I'm fascinated by it. I've never done it before. I'll probably be pretty poor at it when I start. But for my brain function, that's probably a good thing, is it?
Yeah, and specifically related to martial arts. And there are multiple different sports where they've looked at this. But if you match the exertion level during learning martial arts versus some other thing like running, right? We can get the same cardiovascular workout, but there's no movement or coordination challenge, or having to think about not being punched in the face or kicked in the face if you're actually sparring. You get a greater measurable benefit from the martial arts than you do from the running in terms of cognitive function, right? Because there's the additional challenge. The question you asked about doing things that you're bad at, I think is the perfect one, because that then allows you to figure out the things that you might want to do in order to increase the sort of stimulus, prevent the cognitive decline that we talked about earlier. And one of the best examples that I have of that is a study that was done in musicians. And they looked at how old their brains look on a brain scan. So you can do an MRI scan of the brain, and then there's this machine learning algorithm called brain age that basically says, how old does this brain look? You know nothing about this person, but how old does their brain look? And they did a study of musicians, and they had professional musicians and amateur musicians. And compared to the average population, all the musicians had brains that looked younger on the scan than they were in terms of their actual age in years. So being a musician seemed to be beneficial regardless of what type of musician you were. But the amateur musicians had a greater benefit. Statistically significantly younger looking brains compared to professionals, because it's harder, right? Yeah. If you're an amateur and you're not very good at it, then it's more of a challenge. Like that's what the conclusion that the authors came to.
So there's an interesting conundrum here. For me, as I hear that, right, I'm thinking, okay, so someone may hear this and go, all right, I'm in, right? I don't want my brain function to go down. I'm going to learn a new language.
Yeah.
So they sign up for a course, or they buy a book or whatever it might be, and they start learning that language and find out, oh man, this is really difficult. Oh God, I can't do this. This is really, really difficult. I've got a few words. I can't put it together in a sentence. Okay, if they persevere with that, that's going to be great for their brain function. But I guess if they're not enjoying it because they're not good at it, they're probably not going to do it much.
Yeah.
So, help us understand practically what we should do in that situation.
And that's absolutely right. So I think the process of learning and failing, developing a skill that you can probably only do in 20 or 30 minute chunks. If you think about a martial arts class, after you've warmed up and the warm down and the stretching, like how much time are you spending learning new patterns, new movements? It's maybe 20 or 30 minutes in a class. If you do a language class, after you've said hello to everybody and kind of got into it and opened the books and, you have a couple of conversations, how long do you really spend sort of pushing the limits of your language skills? It's maybe 20 or 30 minutes in an hour, because that's really the period of time when humans can really sort of like push on the edges of their skill. So if you think about learning new skills, then that's kind of what you're thinking about. Something that you can spend 20 to 30 minutes, really sort of exploring the limits of what you can currently do, getting a little bit better. And that's it, right? It should be hard after that. And then, you get frustrated or you get cognitively tired, and that's when you need to rest and recover. What you choose to do that, I think, matters a lot less, because of all the things we talked about. Language, we talked about movement, it could be knitting, it could be video games, it could be online brain training. All of these things have been shown to have benefit. And so, yes, just doing something that's hard is going to be beneficial to a certain extent. But if it's not something where you can continuously go back to it because you enjoy it, then you're not going to stick to it. So it's the thing, it's a combination of something where you're learning over time and getting better, but also something that you enjoy, because that's the thing that you're going to do more of.
Yeah, so that's super practical for all of us, whether it's our retired parents or ourselves. It's like, what are we doing in our lives currently that is challenging and that we enjoy?
Yeah,
I guess. And you're saying this sort of 20 to 30 minute period. Are there any specific trials on that, or is that sort of an amalgamation of other neuroscience research that means, we kind of think it's about this time?
Yeah, it's probably at least partly related to focus and attentional capacity, and in other areas, you see something similar. So I'm stealing ideas from, say, the Pomodoro technique, which is where you have 20 or 25 minutes of focused work with then a 5-minute break where you completely detach yourself, because 20 minutes is the period of time when you can really focus on something and devote yourself to it before, again, your mind starts to drift or you go elsewhere. And then if you think about...
Sorry to interrupt. If you're enjoying this video and want to learn more, you can download my free special guide containing 6 simple breathing practices that will help you calm your mind, lower stress, and improve your energy. To get hold of this guide, all you have to do is click on the link in the description box below.
Well, in scenarios where we're teaching people new skills, of course, you're usually trying to fit something into an hour because that's just like the standard unit of time. But in general, like, how long are people really working on these things? And it seems to be something like 20 to 30 minutes. So part of it is practical, but then part of it is based around, on average, that's the period of time when somebody can really focus on something.
Crosswords, Sudoku, do they help?
My guess is a little bit, but probably not nearly as much as any of the other things that we've talked about. Purely because there isn't that kind of challenge or skill in the same way. Maybe cryptic crosswords are their own separate, because there's a skill around cryptic crosswords, right? You need to know what the clues are for what you need to do with either the words or the letters in order to get the final word. A traditional crossword is usually just memory, and that can be useful, but it's not that same kind of challenge. And then again, once you're good at it, so once you're really good at cryptic crosswords, it's probably not the same challenge anymore. Once you're really good at Sudoku, it's probably not the same challenge anymore. And people often like to do those things because it takes 5 or 10 minutes, it passes some time. It's nice to complete something, but then you're in some area where it's not really the same kind of challenge. So maybe, but probably not the same way as some of those sort of more all-encompassing skills that we've talked about.
Yeah, I love this, Tommy. It's super practical. I know we spent a lot of time on this kind of how are you stimulating your brain in a new way, in a novel way that's challenging. We'll definitely talk about food and sleep and movement and stress and that stuff. We're definitely going to get to that, but I think it has been worth really hammering home this point.
Yeah.
In terms of looking at what we can do to prevent our brain function going down with age, I love the way that I've heard you think about this before and say the reason we know what to do is because we know how to create cognitive decline in animal models.
Yeah.
And I thought that's a really beautiful way of us looking at it. So perhaps you could explain your framework and then we could see where we're up to and where else we need to go.
Sure. So again, like I mentioned earlier, in my day job, I'm a neuroscientist, and the vast majority of that is doing work in animal models of brain injury and brain disease, neurodegeneration. I think what you see is that from those models, and what's nice about those models, you can isolate a single thing. So I've been having conversations about this recently in relation to what do you need, what's important for cognitive decline, what's causative in humans. And I've had some conversations around the work of David Smith, who's a emeritus professor from Oxford, who ran groundbreaking trials showing that if you give B vitamins to lower homocysteine, in humans who have elevated homocysteine, you can slow the rate of brain atrophy and cognitive decline, like just with a simple multivitamin. And then there's an interaction with omega-3 status as well. So nutrition, incredibly important. But then there's a question of the homocysteine, which is the thing that you measure to decide whether this person needs this supplement or not. Is the homocysteine damaging itself, or is it just telling you something about this nutrient deficiency? And that's a question that we can't answer in humans because you can't dissociate the marker, the thing itself, from what's causing it to be elevated.
Yeah.
You can do that in animals. I don't think it's been done in a way that sufficiently answers the question that I have, which is that is it just the B vitamins, or does the high homocysteine itself have a causative effect on cognitive decline? And some people think yes, and some people think no. But that's a question you can only answer in animals. But more broadly, you need, there are essentially 3 different ways that you can create cognitive decline in animals. And that's not doing genetic manipulation. That's kind of, I'll keep that separate. Assume that you just have an otherwise healthy rat or mouse. You can decrease the supply of things that are important for the brain. And you can do that in two ways. You can either decrease the amount of those things being around, so nutrients being one, we just talked about some, or you can decrease the flow of blood and oxygen to that area of the brain. You can create like a chronic decrease in blood supply to the brain. And so you're either not providing enough of the nutrients, or those nutrients aren't able to get there. That's one thing.
So on that one thing, that's for a human, that's a poor diet.
Yes.
Not getting enough nutrients in to supply the brain, or it's having, again, a non-scientific term, but furred up arteries so that, you can't deliver as many of those nutrients that you may be taking in to that part of the brain. That's all part of that first thing that you can do to cause problems.
Yes.
Okay.
So any kind of vascular supply, so it could be, and it can happen in the arteries in your neck, the arteries in the brain, and it's usually, it's the same kind of process that happens in the arteries in the heart. It might lead to a heart attack.
Can we just pause on that a second, Tommy? Because a theme, I think, throughout this conversation is that you may not get the diagnosis of age-related dementia or Alzheimer's till you're 65 or 70, but the process that leads to that diagnosis may well be starting in your 30s or your 40s. I know Professor Dale Bredesen, who I've spoken to before on many occasions, the neurologist in America, I'm pretty sure he said, this starts at least 30 years beforehand in the brain.
Yeah, exactly.
So I think that's a key point. So we're going to talk about diet shortly, and also in terms of nutrients getting up. Again, people may be familiar with strokes or heart attacks, where that's a very late stage when actually you've got problems and symptoms. But many of us probably, without realizing, may well have degrees of furring well before that.
Yeah. And so everything happens on a continuum. And you can, you might have this, very acute change or lack of blood flow. That's what we would call a stroke, an ischemic stroke. But you can also just have, and it may not even be, right, if you had a scan on your arteries, you may not even see that there's this huge blockage or anything like that. But over time, again, as your vascular system, your blood vessels, as they age, and that's related to a whole bunch of these very similar things, they become more stiff. And when they're more stiff, it means that they can't regulate themselves the way they normally would. And we do this process in the brain called neurovascular coupling, which basically says that when a neuron is more active, it asks for more blood flow, right? And the muscles do the same, right? When you work your muscles harder, your body diverts blood to those muscles. And the brain should be the same way. But over time, the blood vessels may not be able to do that. So when the brain is asking for more oxygen or it's asking for more nutrients, the vessels don't respond. So that's kind of one thing. You're not getting enough of whatever it is you need to the point. Then another way is to provide some kind of chronic, for want of a better word, toxic exposure.
So this is the second way to damage your brain.
This is the second way to create cognitive decline in an animal model. And you can sort of like poison very specific parts of mitochondria or other things. So like very small, like they've done it with very small doses of cyanide, but you could equally do it by exposing an animal to car exhaust. Sort of more common things that we know are part of the environment. And so those things essentially inhibit either energy production or the ability of the cells in the brain to respond or adapt, or maybe directly damaging.
So toxic exposures, so it could be cigarette smoke, it could be car exhausts, it could be heavy metals and fish.
So heavy metals and fish, so potentially mercury, although if it comes from fish, the selenium and the omega-3s and things like that in the fish may
protect us.
Yeah, may protect us and sort of overcome any detrimental effect there. But something like lead seems to be, and it's very common in some water supplies, even in industrialized countries.
So for years it was in the paint.
Yeah, in the paint, in the pipes.
I mean,
that was part of air pollution, right? Because of leaded petrol.
Of course. I mean, we're only two into the three ways in which you can cause...
There's actually a fourth. I forgot. There's
a fourth, right? So only two of the ways in. And I'm already thinking about what you said at the start about the societal pressures, poor nutrition, poor lifestyles, air pollution, right?
Yeah.
It's no wonder when we currently study populations like there's a linear decline in our brain function.
Yeah.
So with all the good news, let's go more. Let's go to number three.
It's lack of stimulus, right? So we've already talked about that in multiple ways. But if you, the way that we would do that in animal models is we either socially isolate an animal, which is incredibly stressful, and you have to get what's interesting, and it's important. I mean, it's incredibly important for doing high quality animal work that's ethical and that actually helps us move human health forward, which is ultimately the goal. If it's not doing that, I don't think it's worth doing. That, in order to do ethical animal work, you have to, look after those animals as best as you possibly can. And one of the ways that that's ensured is, there are committees at every university that make sure that every experiment that's proposed is sort of as ethically sound as possible. But unless you have a really good reason to, there are two things you're not allowed to do. You're not allowed to socially isolate the animal, and you're not allowed to remove any stimulus from the environment, what we call environmental enrichment. And that can be in terms of like a running wheel for mice, or it could just be like toys or something in the cages. And if you think about humans, socially isolated, lack of cognitive stimulus, like we're doing this to vast proportions of our population, particularly as they get older. And we've taken away social connection, we've taken away stimulus. You're not allowed to do that to a rat in a lab unless you have a very good reason for doing it. But you can do it to a human, no problem.
That is, just to look at it through that lens is completely nuts, isn't it?
Yeah.
Wow.
So that's the third part. And then the fourth part, we kind of talked about a little bit as well, which is that, right, you need the stimulus, you need the things that are required, nutrients to respond to the stimulus, you need the absence of toxins, and then you need some kind of period of rest and recovery. So that's why sleep is critical. But then also absence of chronic stress is probably something you could put into that bucket as well. And you can do this with social stresses, say, in if you're going to do this in an animal model. So we talked about social isolation. That's a chronic stressor, but you can also do it with aggressors. So you might have an aggressive mouse that you introduce into the cage, and then that continuous aggression, which could be discrimination based on your physical ability, based on your race, based on your socioeconomic status. These things that people are exposed to again and again and again. We might model it in that way, and then that's there's a whole host of physiological, immunological things that we can measure that result from that. But cognitive decline and chronic health conditions can be one of the things that come from that.
I just wonder, when it comes to things like fries and crisps, that oxidized fat can stick around, I think, in the body for quite some time. So it's not about demonizing it necessarily, but just helping people understand why they may not be the best choices, certainly in high amounts. I don't want to be too prescriptive, but I think we need to talk about these things.
Yeah, it's a very important question, and I think the natural tendency is for people to basically say they're terrible for your health, you should never eat them, and there's really no evidence to support that idea. Although, like mechanistically, like you say, biochemically, yes, these things can hang around for a long time, but one of the most important aspects of all of this to me is to control the things that you can control, and then the ones that you can't control or you're not willing to control for whatever reason are things that you shouldn't worry about, right? And because I think that the process of worrying about it is worse than the process of doing the thing itself, right? So if you have a bag of chips once a month because it's your treat on a Friday night, I would much rather you do that and enjoy it, and it's part of your overall health and well-being, than worry about what the fat that's on those chips is going to do in your body. Like, I would really hope that you don't do that, because the effect of worrying is probably going to be more significant than the effect of the fat on the chips. So it's very much about just thinking about what am I trying to achieve? What can I meaningfully control that doesn't have a negative effect right? Because if you feel like you're being restricted because you can't have your monthly Friday night chips, that's going to have a negative effect on your physiology. And people who feel more restricted dietarily then have some knock-on effects, like they have higher stress hormone levels and things like that. Like, it has an effect on your physiology. So to the extent that you can and are willing to change something, do that. That's great. It's going to have, it's definitely going to have an effect on your health. But when you get to a point where it feels restrictive long term, A, it's not going to be sustainable, and B, it's going to have a negative effect on you. So yes, I think that people should minimize their intake of vegetable oils and fried and processed foods. I still eat those things, and it's a big part of, occasionally, and it's a big part where it's important to me to, if I'm going to do it, I'm going to enjoy it and then not feel guilty about it, because the guilt is going to be worse than the food itself.
That guilt and feeling bad about something is actually a lot more toxic than people really think. And there's actually really good research. Kristen Neff has done a lot of research on self-compassion for 20 years, which I've only been coming across in the last few months. And it's really, really fascinating. And it really echoes my own clinical experience, which is deprivation and restriction works for a period of time. But if you still feel as though you're being deprived and restricted, you can get all kinds of toxic knock-on behaviors on the back of it. You feel bad. As you say, if you're going to have those chips with your friends, if you're going to do it, enjoy it and understand that, hey, you know what? I'm doing this because I'm with my buddies and I'm hanging out and it reminds us of university or whatever it is. Be in that, because otherwise the next morning you wake up, you're like, man, I shouldn't have done that. I'm a failure. I can't stick to anything. You drink more wine that evening to compensate for that feeling in it. And it's a knock-on effect. And again, this doesn't get spoken about enough, I don't think, in the health and wellness space. It's all very well giving a prescription for healthy living, but how we deliver that prescription, how that prescription is communicated is so, so important. But I just don't think it's given enough credit.
Yeah, this is, and I particularly got interested in this when thinking about, we talked about genetics briefly, the way we talk about our genetics and our health. And we always talk about it from like using this negative language, right? Either you're normal or you have some kind of genetic risk factor or deficit, or this gene isn't working properly. If you listen to people who talk about genetics and health, that's the language that they use. And so automatically you're creating this negative association with something that's inherent to you, and it has a negative effect on your physiology. So they've done experiments where they had people do a treadmill test, right? How far can you run in 30 minutes? Then they did a genetic test, and they told them, based on your genetics, we would expect you to be, either you have a good aerobic performance gene or you have a bad aerobic performance gene. Then they redid the test. Those who were told that they had a good performance gene did exactly the same. Those who were told they had a bad performance gene did worse on average, right? They've been told they have a bad gene for aerobic performance, and they actually got worse on a treadmill test. Now, the thing is that they randomized people to whether what they told them was true or not. So the effect was not in the genes. The effect was in being told whether you had the gene or not, which actually was not true. So being told something negative about your physiology, about something that's inherent to you, has a negative effect on your health or your performance. And this is how we talk about things. This is how we talk about vegetable oils. This is how we talk about genetics. This is how we talk about carbohydrates or protein or meat. And what it creates is that, like, everything becomes this, well, what's the negative effect this is going to have on me? It's never what's the beneficial, what's the benefit? Like, what are the great things that are happening to me right now because of this? And we know, Ellen Langer has done some incredible work on the effects of the mind on physiology, blood sugar control, weight, like body weight. And we just don't give that enough credit. So the way that health experts talk about these things, you're automatically creating this sort of feeling of negativity around pretty much anything in the people who are listening. And that's having a bigger effect, I believe, on the physiology than actually whatever the advice is.
Yeah, it's such a good point, Tommy. There's so many aspects of that to think about. There's how we communicate health messaging. So we always feel that we're slightly inadequate in some way, that, I need to optimize. I need to, I wasn't born with that gene. Oh, but my best mate, oh man, I've got to do something to compensate for my inadequacy. But that sort of mindset, it sort of goes beyond that as well, doesn't it? That not feeling good enough in ourselves, that insecurity that many of us have. I remember I didn't sort of go down that route at the time. I remember you saying that in your earlier days, you used to go on these quite brutal endurance. You'd really, really push yourself, and you sort of laughed it off at the end of a sentence. There was a bit of self-loathing there, and I really noticed that at the time, because I know myself, one of the reasons I feel I can approach the marathon this year with a real calm is because I'm not trying to prove myself to anyone. I'm comfortable with who I am. I've done a ton of therapy over the last 7-8 years, and I feel I like the person that looks back at me in the mirror now, whether I run a marathon or not, whether I finish it or I fall after 7 miles and I'm injured. That doesn't change how I feel about myself. My kids still love me. My wife still loves me. I still love me. And I know my own behaviors in the past were driven from a place of not feeling good enough. So I would define myself. My identity was made up around, if you do that, yeah, you're a success. You are someone. And letting go of that has just given me more freedom in my personal life, but also with my health, I feel. And I don't know, how would you think about that self-loathing you spoke about before, and how do you think that's impacted your journey throughout health?
Yeah, I think most of my health journey actually started with that. I was bullied a lot as a kid. I was a bit overweight, didn't really like sport, didn't really have very many friends. I was absolutely the nerd who wanted the extra tests, was trying to do very well at school, which doesn't often go down well with your peers. And when I was 18, that essentially manifested itself in a hyper focus on my how I looked physically, because I was dumped just before my A levels, and I channeled all of that into the gym, which is the first time I'd ever really done any significant exercise. And like when you're 18 years old, you're like, well, if I get a 6-pack, maybe she'll love me again and she'll take me back, right? And I think this is where where a lot of teenage males may end up going, and obviously not at all helped by Men's Health and Men's Fitness magazines, which I read obsessively.
Yeah, me too.
And I remember, and I was also very hyper focused on like everything that went into my mouth. It had to be very high quality, it had to be completely unprocessed. I had to have cooked it myself. I had to know all the ingredients. This is sort of, I guess, like 18, 19, mainly in my gap year before university was when it was probably at its worst. And I remember when I then got to university, somebody as a joke posted underneath my my dorm room door a thing about orthorexia, which, I mean, this is in 2003, right? I don't think anybody had heard of orthorexia then, right? And like that was really when I was at my lowest. Like I was training 20 plus hours a week. I wasn't really eating very much. I look at pictures back of me, like of me back then. I'm gaunt. Actually, I went to see my grandmother one summer, and she used that word. It was Icelandic, but she basically told me that I was gaunt. And I didn't see it. But like slowly over time, as I became accepted by my peers, as I started to feel like I had worth in other areas, as I like started to be like loved more by others, and I started to love myself and understand myself, a lot of this stuff disappeared. But it's in the background all the time. Like I still think too much about what I eat, and I still think too much about the exercise that I do, but it's sort of just like a little grumble that's in the back of my mind. It's not negatively affecting my health in the way that it used to. But it, like that journey took 15 years, maybe. But because of that, it allows me to see it in others, empathize with it in others, really understand why these things exist, how common it is. And then also, inform some of my approach to how we might think about health and nutrition and stuff. But it's so basically that journey, which has sort of underlied all of my education and professional experiences, has kind of been ongoing and has really sort of laid the foundation of it.
Yeah, thanks for sharing that, Tommy. Super poignant to hear that, and certainly helps us understand some of your passion for health messaging and the way we can and should deliver that messaging. I think emotional health is so important, isn't it? I mean, is there much research on emotional health and brain health? I certainly know there is regard to overall health and well-being and our satisfaction, but with respect to our brains, is there anything there that you're aware of?
Well, they're very intimately connected. And if you think about anxiety and depression, those who have diagnosed anxiety and depression have an increased risk of dementia. Those who have certain types of stress, emotional stress. So particularly, they've looked at this in the workplace. If you have a job that has a high amount of stress, but you have very little control over that, that's then also that obviously has a negative effect on your mental health at the time, but also increases your risk of cognitive decline. So, and these things are intertwined, right? Is it simply the psychological effect, or is it the mind and the body are intimately connected? And we know that a lot of injury processes in the brain have a peripheral component, which could be some kind of inflammation due to some other kind of disease process, which then negatively affects the brain. And these things are in constant communication. So the things that affect our emotional well-being and our subjective stress levels absolutely then can have an impact in terms of our long-term brain health.
Yeah, I mean, we're all on a journey, aren't we, in our health, whether it's as health communicators or just to improve our own well-being. And I certainly think of the way I've evolved my thinking is, yes, food, movement, sleep, stress, super important, of course. But I really feel these days that how we feel about ourselves, self-worth, that emotional health, I'm starting to think that that's actually more of a root cause, because when that's sorted, you often don't need to chase around with food, movement, sleep, and stress, because actually you don't actually compensate for that lack of self-worth by engaging in those other behaviors. So, I mean, that's currently where my head is at the moment. How do you think about that?
I think, because of all the sort of the reasons we've gone over, I'd completely agree with you. And the modern environment, social media, how we interact with others now, I think feeds into this, general negative self-worth. And again, even those of us who are trying to help other people improve their health, we can absolutely make it worse. And I'm sure we actively do that despite our best interest. And I think most people are trying to help. They just don't realize the potential, negative effects of that. But again, I think these things are tightly connected. So if you put yourself in an environment that is supportive of your self-worth and your mental health, yes, that's going to hopefully reduce these sort of negative behaviors that can have a negative effect. But I think the nature of that environment can also support better habits or better processes in those areas. So, if you're in a place that is actively supporting your self-worth, you're probably going to sleep better. And you're probably, getting either making or sort of being exposed to better food choices and better social connection, and you're less subjectively stressed. And I think if the environment changes, then many of these things are going to change, and these things compound over time. So we know that people who start to exercise more are more likely to change their diet, they're more likely to stop smoking, they're more likely to sleep better. And these things sort of, they're intimately connected. So yeah, I mean, the environment that we're creating currently is probably having this huge effect on our self-worth that is then negatively impacting all these other areas. And then it might be from person to person, a different area is the route in. Maybe it's a focus on sleep, which then improves mental health and self-worth, which improves, your diet or your movement or whatever.
Yeah, I think there definitely is a different route in for different people. You can enter that circle at any point, and it can start to feed all the other components. To sort of close this off, Tommy, there are two other areas I wanted to talk to you about in relation to brain health was sleep and connection. Now, I'm super cautious, given what we've just said, that we don't stress anyone out as we talk about a lack of sleep and brain health and a lack of connection in brain health. So let's keep that at the top of our minds if we can, which is always difficult. But how did those two things potentially impact our overall brain health?
So sleep has become, thankfully, sexy again, which I think is fabulous, because it really did used to be sort of like society said, sleep when you're dead, get the work done. It's something that you can reduce, and you'll just don't worry about it, pay for it later. And you really do pay for it pretty much right from the start. So I'm really glad that people are starting to focus on sleep again. And I also think, and this is something that I've learned from my friend, Dr. Greg Potter, who's my own personal expert in circadian biology, and we've published together and worked together on some projects. And he'll tell you that actually we don't sleep as badly as we're told we do. And the majority of people probably sleep enough. But, if you're not spending 7 hours in bed, all things being equal, you're probably going to be better off from a mental health standpoint, a long-term brain health and physical health standpoint, if you do get to spend 7 to 8 hours in bed, and then you get to spend most of that asleep. And we look at both sleep quantity and sleep quality. Both of those are important for long-term risk of cognitive decline. And though it's difficult to really unpick it, we probably can't pharmaceuticalize our way into that. So if you're taking sedatives in order to achieve that sleep, you're probably not going to be getting all of the benefits, because the nature of that sleep isn't the same. So I don't think our sleep is necessarily as bad as we're told it is, but for the people who aren't sleeping well or long, and it doesn't, again, like 7 to 9 hours is probably the average that you might want. Then I think there's definitely going to be some benefit to improving that if you're able to spend that extra time in bed.
There was one paper I think I saw you present once, Tommy, where decreased sleep, yes, increases reactivity in the amygdala, the emotional part of the brain, but also I think you shared something where it decreases empathy, which I found really interesting.
Yeah, so this was those things were actually from the same paper, looking at how we react to visual cues in other people's faces when we're sleep deprived or not. And when we're sleep deprived, and acutely, it's going to happen in one night of sleep. And again, the important thing that other studies have shown that is that one night of bad sleep does not have any meaningful negative effect on your health, right? So, overall, we're talking about these things compounding over time. So if you sleep badly one night, it's not something to worry about. Again, it's just it's fine, and you'll survive just fine. You'll have no long-term negative effects. But when people are sleep deprived, you're less likely to be able to recognize a positive emotion or change in somebody else's face. You're less likely to be able to empathize with them, and you're more likely to see something as negative. And again, so when you think about people sleep deprived in meetings, on Zoom calls, interacting with others, meeting new people, when you're sleep deprived, it's more likely to be a negative experience. And again, I think this stuff compounds over time. So this is one of, if you want to be a well-rounded, socially connected, sociable human being, sleep is incredibly important. And that's in that study, that was one of the reasons why that was found to be the case.
Yeah. I think we all know that intuitively. I mean, going back to how do we feel, we can talk about sleep and ask yourself the question, each morning, how do I feel? Was that enough? Do I feel refreshed? Do I need a little bit more tonight? Was that a little bit later than is best for me? Just finishing off there then, Tommy, on connection. And, I guess some of the softer stuff, or what we used to think was the softer stuff. I don't think I learned anything about the power of connection at medical school now, thinking back. Maybe I did, maybe I've forgotten about it. But just how important is connecting with others for our brain health?
When you really boil it down, social connection, again, is essentially the sort of foundational aspect of us as a species, right? We are a collectivist species. We benefit from being part of a social group, from having a place in that social group, from having a purpose within that group, which gives us meaning. And having meaning is something that tells our body that it's worth being alive. Having meaning or not seems to have an effect on the immune system, has an effect on our physiology. And so without social connection, you're essentially not giving that input, which is that you have purpose, you have meaning, you belong. And that is one of the critical inputs for the brain to keep working. And one of the downstream or threads that comes out of this demands-driven theory of cognitive decline, which we talked about earlier, is the grandmother hypothesis. And so the grandmother hypothesis states that, rather than when you've procreated, you are essentially just a useless sack of meat, which is what some people will tell you about the evolutionary forces on our bodies, right? That you're just there to procreate. Once you've done that, there are no more evolutionary forces that are creating fitness, right? And so, like, most people will say that your genes are just there to make you live to 20 or 30 years old, procreate, and then what happens after that doesn't really matter. However, the grandmother hypothesis would state that if you are useful and healthy longer into life, then you are available to help support your progeny, their progeny, and to keep your tribe alive, right? So you are actually increasing the likelihood that your genes will be passed further into the future by being alive to be able to help the new parents or being able to look after the grandchildren. So actually, there are evolutionary forces that exist to keep us long and healthy for as long as possible. However, you get to a point where you are no longer of use to the group, and then that's probably going to be a trigger for some kind of decline, because as soon as you're no longer of benefit, if we think about this from an evolutionary perspective, we think about hunter-gatherers, early humans. As soon as you're no longer of benefit, you are a detriment to your tribe, to your group. You're going to take up resources. People are going to have to care for you, which they can't really afford to do. So that could trigger this period of decline. You think about wolves or dogs leaving the pack when they're old so they can go and die peacefully in the wilderness. And humans used to do that in some groups as well. So we are only giving ourselves the input that says, you're worth being here. You're worth having some kind of function because you're part of a group and because you have purpose. And without social connection, it's almost impossible to have any kind of significant purpose, because you don't know that you have purpose because you're not contributing to some kind of goal or group that's greater than yourself. So I think that, we've kind of bounced back from the philosophical to the physiological, but at some level, for us to survive and be healthy and functional requires some kind of social input that says you have meaning, you belong, you have purpose. And so that's going to be critical to physical health, mental health, cognitive function. And that requires social connection. It requires other people to help you see and learn that. And so without that social connection, I think that is probably a significant trigger for decline in health and decline in cognitive function.
If you enjoyed that conversation, then I think you are really going to enjoy this one.
I love sugar and I love pasta, and I did not want to give those up at all. So I had to figure out, how do I still eat all these glucose-containing foods in a way that doesn't create the spikes? People need to know this because it can really transform your life and avoid a lot of suffering.